Hey and welcome back, final part in the series on the spiral planer thicknesser we recently purchased from Axminster. Today we're going to put it through its paces and see what it can do. That sounds good, stick around. Welcome to the Woodgrafter. I'm Andy Guile. Our mission here is to inspire, educate and support you in your journey to becoming a better woodworker. We have a whole variety of videos from tool setups, techniques, how to use tools safely, videos such as this one, and step-by-step project builds taking you every single way through the creation of something of beauty and value. So if you're not a subscriber, consider subscribing now, give me a thumbs up, leave a comment and just get involved in what we do. Let's get going. So we're finally here, the final episode in the series about the AT260SPT, the spiral planer thicknesser from Axminster. So far we've unboxed it, we've put it on its mobile base, we've cleaned it up, we've set it up and we've calibrated it ready for use. And today we're going to put it through its paces. Before we do that, I had a great question from one of our community. Why did you buy this one, Andy? This model in particular? Why did you buy it? So let me just quickly talk you through the features that got me to my buying decision. So the first thing was about the size. I wanted a machine that could specifically fit into this space here inside my workshop. And if you've followed the Woodgrafter for a while, you know that the space that we're building our workshop in to run the business from is nothing more than 1.5 size garage. So this had to fit into the available space. Would I have liked to have gone bigger? Absolutely. And bigger would have given me a wider capacity on the bed and a longer capacity as well. But this one fits in perfectly. The second buying criteria that got me to this machine was the capacity of this machine in particular. The stock that I buy in from my supplier tends to be 2.5 meters long and tends to be 200 millimeters wide. So I wanted a capacity that would allow me to manage that size of stock. Now in terms of the jointing capacity on the top, I have a maximum capacity of 260. So that's more than adequate for the 200 millimeter stock I tend to buy in. In terms of the thicknesser at the bottom, I have a capacity of 260. So again, more than adequate for the stock that I came in. I knew I wanted to go for a spiral cutter. And I wanted a spiral cutter for 3 reasons. The first and I think most important reason is the quality of the finish. You get a much better quality finish with a spiral cutter than you do with a straight blade cutter. And that's because you've got multiple cutting faces all hitting the material at an angle, giving you more of a skew plane than a direct plane, which is easier on the wood and reduces tear out. The second thing about the spiral cutter is the noise. I wanted a machine that was relatively quiet, and a spiral cutter gives you a much quieter cut with much less vibration than a straight knife cutter. And the final part of this is the size of the chips. I do need to upgrade the dust extraction for this machine inside the workshop, but the chips that are created from this are relatively small. So this is what the chips are coming out. You can see that they're very, very fine curls and very, very fine shavings. On a straight blade cutter, you tend to get quite long, chunky bits of material coming out. That's got the opportunity to block the extraction, and you need a much more powerful extractor than you would with a spiral cutter. So it allows me to put a smaller unit. And eventually this space here is going to take some level of dust extraction specifically for this machine. So that gives me more options for a smaller unit in a smaller workshop. So there were the 3 spiral cutter reasons: the quality of cut, the noise and the small chippings that it creates. Now, as we get into building furniture and cabinets, you'll start to see my overall work process, and I tend to work on a module at a time. I find that if you batch all your material out and get it all joinery ready, it can move and distort due to movement. So I personally like to mill material and use it quickly in the sub-assembly and then do the next sub-assembly. So I'm in a situation in my workflow where I'll be changing frequently between the jointing operation and the thicknessing operation, and I wanted a machine that was relatively quick to do that, and this machine gives me that. So really they were my buying criteria: something that can fit into this space, something that had a spiral cutter block inside it, quality of cut, noise of cut, size of chippings, and something that was quick and easy to change between its variable functions. And when it's not in use, something I could quickly push back against the wall to get it out of the way reclaiming this. So something not overly heavy. It's heavy, but it's manageable, especially with the mobile base. That was it. That's why I bought this. Now, when you look around the marketplace, Jet also do something of a similar sort of capability and a similar model. But for the price range that this came in from Axminster, it's a lot more economical to run this than the Jet. And when I looked at the various machines, I couldn't see any noticeable difference. And having put this through its paces and read the reviews, that was the machine I went for. So that's what I look for in a machine. Your situation could be different, but that's what I look for. Okay, let's put this through its paces then. If you don't know what a planer thicknesser does, it turns rough sawn stock that comes into my workshop like this into joinery ready material like this. And this is a piece of ash, and you can see the difference overall. Now, the reason I want to buy rough sawn stock rather than finished material is wood moves. And very often when you get that finished material from a supplier and you bring it into your shop and it acclimatizes, it will shift and you tend to get bows and cups. By bringing the rough stock into your shop first, allowing that to acclimatize and the movement to happen, and then milling it, you avoid that situation. So that's why I wanted it in my workshop, to turn rough cut stock into cabinet quality materials we can use in our projects. Combination of economy, combination of accuracy. And if you know me by now, I love accuracy in my work, so it's a logical step for me. I've always used rough cut stock, and I used to bring it down by hand using hand planes, which is eminently doable, but takes a long time. And this takes the work out of that, and in a production workshop where time equals money, that's a good positive thing. So it's going to speed up the workflow, arguably give me more accuracy within my finished products, and allow me to buy and store rough cut stock and mill on demand. So our test piece today is this rough cut piece of ash, and you can see it's got some challenges. It's a really challenging piece of material. I've got quite a nasty hump here on this side of the material. I'm not sure if it shows up in the camera, but I've also got a little bit of a bow and a bit of a rise here. And we're going to bring this nominally 25mm piece of stock down to 18mm that we could then use inside a project. The first thing I want to do is to get a flat surface, and for that we use the jointer. So let's talk a little bit about safe operation. And before we do that, notice I've got this thing unplugged. I do not go anywhere near this blade if this thing's connected to the mains. Check number one. This high-speed spinning blade is your danger zone. So you want to use this in a way where that blade is always covered, either covered by the stock or covered by the guard. So if I just demonstrate what I mean on this offcut of mahogany, if I wanted to put a flat side here and get rid of this rough stock, if I just take it straight over the cutter blade like this, you can see I've got this side of the blade exposed and this side of the blade exposed. And that's a great opportunity to take off some fingers. And if that's what you want to do, excellent news, but it's not what I want to do. So we use the fence in, and we bring the fence in to a point where the blade is covered as that wood is passing over it. So now as I'm going over the cutter block, there's no way that my hands can get anywhere near this cutter because it's covered by the material, or it's covered by the fence, or it's covered by the support at the back of the fence. That's the design. So step one is you always adjust the fence for the stock that you are using, which is good. Step two, you want to ensure that you never actually put your hand over the cutting area. And what you want to be able to do is to move the stock along, move your hand over there to the front edge across the cutter, bring this forward, move your second hand across the cutter, and then complete the stock. And to make that even safer, that's where this second guard comes in. So you raise this guard up so it's covering the material. You bring your fence in so it's covering the back of the blade, and lock everything down, and then you put this guard across to the fence and you position that so it's just clear of the wood. And now you can see, even before I'm using the stock, the blade is covered. Unless I do something stupid like push a hand under here, I'm not likely to accidentally catch this guard. And also any loose clothing I've got on would not catch either because everything's protected. And now I've got a very safe operation. I can bring my stock in, I can push it through the cut, move my hand over, and then pull the material through the cut, feed it through like this, and that's going to give me a very, very clean cut. Now the next thing you want to think about is your technique. if you put lots of pressure down on this board, and this board has got any bow in this sort of direction, all you're going to do is to push the bow out. So you'll come along, lots of pressure, you're pushing the bow out, and yes, you'll get a beautifully clean surface, but when you let go of that, the bow will come back, and you're not going to get the flat stock that we're looking for. Now the safe use and the safe operation is you don't want to be putting any pressure down on here. All you're doing is you're a driver, you're just guiding this through the machine, and I just have enough pressure from my hands to pull this stock through, like this, safely. And that way it will take out the high spots, leaving you with a beautiful smooth piece of material. Now although the machine comes with push blocks, I don't tend to use these push blocks. Now although these will grip the material for you, and you can use the same technique, we come along, lift the block over, and then just pull the wood through, you can use this, and it's quite a nice way of working, but there's a tendency to push down with push blocks. I find by just using my hands to feed the stock through and then pull the stock through with very, very light pressure, I avoid that temptation of putting down because I'm more in tune with the wood. Now we're going to go and make a cut, and as we make this cut I want you to listen to the noise the machine makes as it's cutting, and once it's taken a high piece out you'll hear it go "nyeh," and then you'll just hear the motor running freely until I get to the next high piece and it'll go "nyeh." Now once I'm getting that "nyeh" consistently all the way across the board, and I can feel through my fingers it cutting across the board, that's when I've got a straight face. So listen to that sound, and we're going to go ahead and we're going to take this side down. Now we'll talk about grain direction in another video, but you want to make sure that you're cutting with the grain. I know the grain on this board is rising up in this direction, therefore I'm going to feed it through in this direction, and that will prevent tear out. Let's go ahead and make this cut. Hear that cut? Now it's not cutting. Cutting. Now what I end up with is a nice flat surface. Remember how that rocked before? There's now no rock in that whatsoever, and that's a beautiful job. Now that took about what, 5 passes? So that's probably taken about 5 millimeters of this side of the board. Now that's worth remembering, because when you're milling stock you want to try and take the same amount off both sides of the board. So we know we've done about 5 millimeters off this side of the board, so when we come to thickness of wood we'll take 5 millimeters off this side of the board, and then we'll alternate the cut till we get down to final size. The reason that's important is that allows the wood to release moisture consistently. If you come through and take everything off one side, you're releasing more of the trapped water inside on one surface than you are on the other surface, because this surface is pretty much dried out, and that will introduce cup into your board. So bear that in mind. Take the same amount off, keep track, about 5 millimeters taken off there. Not quite precise, about 5 millimeters. Okay, so I've now got a flat reference edge. I'm now going to use that against my fence here to give me a square side. Same rules apply. Adjust your fence to expose the minimum amount of cutter that you can, which is about there. And now I want to bring and lock that down. And now I want to bring this fence up here until it's almost touching the wood, lock that down, and now I can lower this down to just protect my fingers once again. Just check your wood can go all the way through, because it is obviously a bit of a knobbly piece of wood, so you want clearance. And once you've got a clean cut, we now go ahead and we run this past. And now what I've ended up with is a beautiful flat surface here, and as long as my fence is square, this edge here is beautiful and it will be square to this edge. That is beautifully square all the way down. Now that's the first part of the process done, and it's given me this beautiful surface. If you look at this and then compare it to where it started, which was something like this, that's amazing. And that took, what, 5 minutes or so to get me down to that level of excellence with this beautiful pristine flat reference edge that I know is exactly 90 degrees square to the face edge. That's what it does. That's the jointing process finished. I now want to go to the thicknessing process. So I now use this as the reference surface. We're going to change the machine over to its thicknessing. This will then reference on the base bed, and the cutters are now in this direction, taking off the stock from the top. I'm not sure you can see on the camera, but my grain is clearly raising up in that direction. So I want my cutter to be hitting it like this. So therefore we're going to slide the material through in that. And as I say, I'll do a separate video about reading wood and grain direction and the importance of it. But for now, just look where that's rising up and make sure your cutters are stroking it in that direction. I now want to work out how thick this material is. And I just use my calipers for that. And it's just a rough indication, so don't go mad. Just try and find a wide area of the board. And that is currently coming in at about 24 millimeters. Now the reason that's important is I want to take a light pass off this first of all using the thicknesser, and then I'll slowly work down to size. Remembering that once I've taken 5 millimeters off this, I'm then going to take material off of both sides of the board. So 24 is the measurement I'm looking for. And now I'm just going to set 24 millimeters on that gauge there. So now this bed is 24 millimeters from the cutting edge underneath here. My rollers are engaged. Now I just want to lock that back into place so there's no movement, and we're going to do the first pass, taking the material from this end of the machine now, allowing for that grain direction, and this should take off the lightest of passes. And you can see it's taken off a spot here and a spot here, but not yet touched the rest of the board. So I'll now increase this by 1 millimeter. You can see this end of the board now is nice and flat, but I've still got these low spots here. So this part of the board is now flat, but here I've still got these low spots, so we'll now bring it down to 19. So you can see what we've got now. We're now getting this beautiful flat surface here, but I've still got a low spot here, and I've still got a low spot here, and I'm down to 19 millimeters in the thick middle of the board, and we of course were aiming for 18. So what I'm going to do, I'm going to take 0.5 millimeter off this, because I've already taken 5 millimeters off, and I want to take the same off on each side. So I'm going to take 0.5 millimeter off this and see where we end up on this low point. Now this board is now down to size, and allowing for that initial hump in the middle of the board, I've taken round about 5 millimeters off each side of this board. At this point I'd need to make a decision. If I was aiming for 18 millimeters, I would actually just rip off these parts here at the middle and at this end that are giving me the low spots. But for an experiment, I want to get this perfectly flat, so I'm going to take this down to 15 millimeters. I'm going to take another millimeter off this side to get rid of these low spots, and then we'll alternate it, so we take the same amount off each side of the board and see what we end up with. In theory, these two faces are now parallel to each other, and this edge is square to both faces. Let's check ourselves and see. Yep. 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 Turning it end for end. Come off the same reference surface. Yep. Now that just leaves us one edge here that's not prepared. Now normally you would rip this down on a table saw. For an experiment, I'm just going to run this through the thicknesser to take it down to 145 millimeters. We've got a board that's coming in at, it's tricky this for the camera, 144.76. So about 1/4 of a millimeter out of my calibration that I can now correct by just adjusting that gauge. But look at that for a finish. It's absolutely beautiful. And remember where this piece of wood started, we've now got a beautiful 4 square piece of wood in no time at all with minimal effort. And that piece of material is good enough to drop into any of our fine furniture projects. I also had a play and I took down some oak to this beautiful piece of stock here. And I also took this mahogany down to this piece here. And this mahogany has come out beautifully. I'm not sure if you can see it. Would you see the sheen on this? That's absolutely gorgeous. And everything's bang on, everything's perfectly square, and the machine is effortless. I have currently got this hooked up to a 1.5 horsepower standard shop vac. It's one I've had kicking around the shop. I just used to hoover the floor. And that gives me 183 meters cubed per hour of airflow. The manufacturers tell us we need 1,000 meter cube per hour of airflow. This is not good enough. It's about 20% of where it needs to be for the recommended dust collection. But it was doing an okay job. I mean, it's usable. I've got a bit of cleanup to do, but it's usable and it's probably acceptable. And there's no dust in the air, so it's just those larger chips that were falling down. I will be looking at dust collection and dust extraction in a future episode, and I will be upgrading the workshop to give me some better dust extraction. Now I'm introducing larger tools and just the Festool system we've used to date. So watch out for that series when I come into it. But that's it. I'm really pleased with this machine. It's a really excellent purchase. It's not something I'm ever going to regret, and you're going to see it used time and time and time again in future projects. Hope you found this useful. Anything you want to know, ask the questions in the comments. Anything I've not covered, let me know. We can always do some follow-on videos. But for now, thanks for watching and I'll see you next time.